Aloha class, homie Holmes has not been in a video lately, so he wanted to show you the skill cheat. Blink. I missed it. All right. Homie missed it. Hold on. The board came back. I missed it. All right. It didn't come back. Section 9.3 part 2. Let's roll this bad boy and get it done. I know some of us have been struggling a little bit in this lesson, so please make sure you come in for help if you need it, okay? We're doing, remember, Taylor and Maclaurin series. Okay, Taylor or Maclaurin series looks like this bad boy, okay? Now remember, we are going to use an equal sign now. Now, why can I use an equal sign? Because I list every single term possible, right? And then I can even write that equal to a general term. Okay, and remember, if C equals 0, then we call that a Maclaurin series, okay? But that is why we use an equal sign instead of an approximated sign. If I cut that off like n equals 5, n equals 6, or the first 4 non-zero terms, it's just an approximation. And being that this is equal to an actual function, if I center it around a particular value, right, class, we want to know, when is this dude good to go for? So we find the radius of convergence or the interval of convergence, okay? Now, unable to get really good at this lesson, we want to be able to find Taylor series, all right? So here we go, and be able to write general terms. All right, so for the following, find a Taylor series for f of x equals e to the 5x centered at c equals 2. Find the first 4 non-zero terms and the general term. So how would I do this? Well, we all know we start with f of x is equal to e to the 5x, right? And then we take the value of that at 2 since it's centered at 2, and I get e to the 10. Now, what would f prime of x be equal to? Well, that would be 5e to the 5x, right, class? And f prime of 2 would be equal to 5e to the 10. F double prime. Now, how far do I have to go? Well, if it's 4 non-zero terms, I just need the third derivative, remember, because the first term comes from this little f guy right up there. That's 25e to the 5x. And then that would be the second derivative. Add 2, that'd be 25. Wow, they all have e to the 10 on it. Now the third derivative, and that's as far as I need to go. What would that be? That'd be 125e to the 5x. Apologize again for the big pen. And that'd be 125e to the 10. Boom. There we go. All right. So I need the first 4 non-zero terms. Remember, you're doing a Taylor polynomial. So I better have x's in it and all that good stuff. Remember, these guys just help with the coefficient. So here we go. F of x is equal to, and I'm going to use the equal sign because I'm going to write down every single one of them. All right. So we got f of x is equal to, we got e to the 10. That's the first non-zero term. Plus, we have 5 e to the 10, x minus 2 to the first, all over 1 factorial, plus 25 e to the 10, x minus 2 squared over 2 factorial, plus 125 e to the 10, x minus 2 to the third, all over 3 factorial, plus plus. How the heck do I write the nth term for that bad boy? Well, let's look at it. Well, it's got an e to the 10 on it in every single one, so let's keep that boy on it. We have an x minus 2, right, in that guy. And if I look carefully, it goes up by 1, so that would be an n, and I'm going to divide that by n factorial, right, class? Do I need anything else? Well, looks like it's going 5 to the first. Actually, 5 to the 0, 5 to the first, 5 squared, 5 cubed, right? So we can go 5 to the n plus da-da-da. And that is perfect, right? And that is actually equal to the series. And remember, let's check. I should check, right? We're going to start at 0. So let's plug in a 0 and see if it works out. 5 to the 0 is 1. X minus 2 to the 0 is 1. 0 factorial is 1 e to the 10. Let's check the next one. Plug in a 1, and a good to go. So then we're 5 to the n, e to the 10, x minus 2 to the n, all over n factorial. You're going to have to be able to do all that stuff. Make sure you're okay. Make sure you are doing and completing your worksheets, okay? Now we have to read a little bit. So let's go ahead and look. There are 4 special Maclaurin series you must must know. And you'll know why when we do some examples in a little bit, okay? These are the series for e to the x sine x, cosine x, and 1 over 1 minus x. These series under the operations of calculus behave like the functions they represent on their interval of convergence. For a series with a finite interval of convergence, such as the series 1 over x, taking the derivative of the integral will not change the radius, but may change the endpoints. Okay, so if we take the derivative or antiderivative, it's not always going to be the same, right? It says right there, our radius of convergence will be the same, but the endpoints you may have to double check. Once we have these series memorized, we can use these very conveniently to manipulate them or to suit other similar non-polynomial functions as we did in the previous sections. Okay, when can we use these guys? Well, 1, substitute into a series for x. 2, multiply or divide by a constant or a variable. 3, add or subtract 2 series. 4, differentiate or integrate a series. It may change the interval, but not the radius of convergence. Very important to pay attention to that. And 5, recognize that the series is the sum of a geometric power series. Don't worry about that. We'll tackle that next section. All right, now let's go over these guys that you must have memorized. And able to do that, we're going to go to our blank sheet right here, right? E to the x. And I think we've done some of these in class. All right, if not, here we go. E to the x would be 1 plus x squared over 2 factorial plus x to the third over 3 factorial plus plus. Okay, what would the nth term be? Well, the nth term, we go up by 1, so it'd be x to the n. On the bottoms, we go by 1 and factorial. Put a 0, and we're good to go. Plus equals, right? Now I can write it as a summation, okay, of x to the n over n factorial. Have everything about that memorized. Gaze? All right, sine x. What the heck is sine x? Well, sine of 0 is 0, so then we go right to the x. So it's x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7 over 7 factorial plus. Okay, I've got an alternator. I'll worry about that exponent at the end. It's got to have an exponent on it because it's got to alternate, right? Starts positive, negative, positive, negative. Okay, now I go by 2s. Whoa. Let's win that game. Senior night, go away. All right, I go up by 2s with the x's, so it's going to have a 2n on it. Okay, but they're odd, so it's going to be 2n plus 1. Right? And I'm going to also divide by that 2n plus 1. Now, if I start at 0, am I good to go? Let's see. 0 in there would be x to the first. 0 in there would be 1 factorial. Good to go. Now I just have to make sure I start out with a positive. And I could do that with an n right there, right, class? That's good. That's good to go. That matches it up. I could check 1 or 2 terms if I wanted to. And that is equal to plus ... which is equal to the summation n equals 0 to infinity of negative 1 to the n, 2 to the n plus 1, all over 2n plus 1 factorial. Have everything about that bad boy memorized. All right, next one. Cosine x is equal to 1 minus x squared. How did I know 1? Cosine of 0 is Ichi. Okay, so if you ever forget, cosine of 0 is Ichi. Sine of 0 is 0. That's why we start with the x with the sign. All right. Here we go. These are the evens, remember. 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus plus. Oh, there is an alternator. So let's go negative 1. Does it start out positive? We learned last time. Just put an n up right there, right? We're going to start at 0. Okay, my x's go up by 2, so that means it's going to be 2n. And guess what? That works out beautifully to give me the 2, 4, 6, 8, 10, 12. All right, plus which is equal to the sum n equals 0 to infinity of negative 1 to the n, x to the 2n, all over 2n factorial. Have them all memorized. Keep on writing them out, right? You write those bad boys out, you're going to have them ready to go. Now, here is the fourth one. Okay, we haven't looked at this bad boy yet. Or you know what? I think maybe we did in class. That is 1 over 1 minus x. Well, let's do it. Let's do it. Okay, who knows in the future? Maybe in the future we didn't do it in class. All right, so we haven't done this one yet. I don't think so. If we did, then hey, fast forward. But here we go. Let's go ahead and find this Taylor polynomial or Maclaurin polynomial centered at 0. So we start with f of x, which is 1 over 1 minus x, which would be equal to f of 0 since it's centered at 0, which would be 1. Now, what would the derivative be? Now, let's recall that this right here is really 1 minus x to the negative 1. So that ends up being a chain. So we drop that negative 1, x minus 1 to the negative 2, but it chains, and it will make that positive. Let's plug in that little 0, and I get ichi. Okay, so now let's go to the second derivative. Okay, drops that negative 2, x minus 1 to the negative 3, but I got to chain that negative 1 out, turns it into positive. Let's plug in a 0. If I plug in a 0, I get ni. Okay, let's find the third derivative. And I'm sorry, again, it's so big. Negative 6, x minus 1 to the negative 4th. Chain that guy, turns it positive. F triple prime of 0 is equal to local. Okay, let's find the fourth derivative. I'm stopping with this bad boy. Negative 24. Guess what's going to happen to that negative, class? True blue, Scooby-Doo. Right, we get rid of that bad boy. That should be in parentheses there. Of 0 is equal to 24. Okay, all right, let's list these guys out. So f of x would be equal to 1 plus 1x, right? Plus 1x plus, ooh, snappity-dappy, yeah, that's over 1 factorial. And plus 2x over 2 factorial, right? Plus 6x, ooh, squared. 6x cubed over 3 factorial. Plus 24x to the 4th all over 4 factorial. Plus da-da-da. Ooh, nth term might be a little bit tough, so I'm going to cheat a little bit. Let's use the approximately equal to sign right there. Approximately equal to. No, we'll go equal here because I think now I can figure it out once I simplify. Those two, shling, plus x squared. Oh, 6 over 3 factorial. Well, what's 3 factorial? 3 factorial is ichi-ni-san. 3 times 2 times 1. That's 6. So those bad boys are going to cancel out. So that's just x to the 3rd. All right, let's go to the next one. 24 on top. What's 4 factorial? What if 3 factorial is 6? You add the 4. 4 times 6, 24. Right? Those guys, guess what? There is a pattern going on here. Those guys cancel themselves out. So this guy's easy peasy Japanesey. That's just x to the enzo. Right? We don't even have to divide by anything there. And so then we're plugging in a 0 or 1. It checks out plus ... which is equal to the sum n equals 0 to infinity of x to the n. So that's the next one you got to know, and you better have that dude memorized, all right? Now, why does Mr. Tanaka tell me to memorize these bad boys? Well, let's get back to our worksheet here where we got our sweet problems. Let's go up a little bit. Okay, what's this one say? Example 4. Hopefully we got enough room here. All right, they give us f of x, f prime of x, and f prime of 0. Do you recognize this familiar function? Well, you should recognize that from the bad boy, but let's do what they're asking us to do. They're asking us to find f prime of x. Well, f prime of x, let's do derivatives. Sorry. All right, the derivative of 1 is 0. The derivative of x is 1. The derivative of x squared would be plus 2x over 2 factorial. The next derivative, x to the 3rd, would be 3x squared over 3 factorial. Okay. Plus, plus, we can do it with n's in there, right? That's the power rule. Nx to the n minus 1 over n factorial. Okay. Plus, and that's exact. And they're asking me, well, can I simplify that? Let's simplify that. 0, I don't need 0, so we'll go 1 plus x. Okay. Plus, oh, that 3 right there cancel. That's a 3, 2, 1. So it'd be x squared over 2 factorial, right? Because there's a 2 and a 1. Okay. So that probably means the next guy would be x to the 3rd over 3 factorial. What? That's the same as the original. No. For reals? And then we got plus dot, dot, dot. And then some of you are going to say, well, the nth term doesn't work out, Mr. Tanaka, but the nth term kind of does, right? So we got plus dot, 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 plus. All right, believe it or not, that n can cancel out with an n in the bottom. And if I do that, I get n to the n minus 1 over n minus 1 factorial plus dot, dot, dot. And get what the what? So what is f prime of 0? Well, 0, all the x's would turn to 0, and I'm left with ichi. So f prime of 0 is 1. Now, does this look familiar for some reason? Let's see here. Let's do this in blue. That's e to the x. So if I knew that this original Maclaurin series was e to the x, I could have just did the derivative of e to the x, which is e to the x, and plugged in a 0. What is f prime of 0? What is e to the 0? It is ichi, ichi, ichi. What? That was pretty sweet. If you were able to recognize that, look how easy you were able to get that problem done. All right, here we go. Class example 5. All right, you had to start a new page. I apologize. And go potty pots. All right, here we go. So let's keep rolling here. Example 5. All right. This one asked me to find f of x. So they're asking me to find this capital F dude, right? Which that means antiderivative usually. And it does in this case because f of x is equal to the antiderivative of f of x. Okay. If I'm cheating here, I'm just going to do this and this. All right, so let's go ahead and write that out. What would that equal? All right, negative x. So that'd be negative x. I'm going to add 1 to the exponent and then divide by it. Right, class? Okay, so then we're at plus. What would I do for the next guy? I would add 1, which would be 4, right? But then I have to divide by 4, and there's already a 3 factorial there. So it'd be a 4 and a 3 factorial, which would be 4 factorial. Okay. Minus, let's add 1 to that guy. I get x to the 6, but then I have to divide by 6, and there's already 6, 5, 4, 3, 2, 1 on the bottom. So I could just write 6 factorial. Okay. That looks kind of familiar. Plus, plus. All right, what would I do in this case? Well, let's just keep rolling, right? It's got that alternator, so that dude's probably going to stay. I'm going to drop that 2n plus 1. Well, not drop. You're not. Oh, no. Can I not erase? Come on, tell me I can erase. I can't erase, right? I almost took the derivative. We don't want to take a derivative. We're going to add 1 to it. So it'd be x. Apologize for that. So it'd be x to the 2n plus 2, right? Now I'm going to have to add that guy to the bottom. So then there would be a 2n plus 2 factorial in the bottom plus All right. Now, what do they ask me to do after I do that? Well, remember, when I take an antiderivative, it's got to have a plus c on it. Now, plus c is going to be a constant. Where do you think I should put that plus c? I will put it right there at the beginning. Now, remember, whenever a c shows up, you find that c. And what does this tell me to do? It means me to put 0 in for all of the x's and a 1 in for that. So we'll go 1 equals c plus 0, 0, 0, 0, 0, 0, 0, 0. So what does that mean c equals? That means c equals ichi. So that means f of x is equal to 1 minus x squared over 2 factorial, because 2 is 2 times 1, right? Plus x to the 4th over 4 factorial, plus x to the, minus x to the 6 over 6 factorial, plus plus negative 1 to the n plus 1. Okay, and then what do I have here? X, ooh, don't tell me again. No, tell me it's not so. So we got x to the 2n plus 2 all over 2n plus 2 factorial. Okay, now does this guy work out? And if this guy works out, we are money. Well, what would we let n equal in all this bad boy, right? Well, we don't even have to write this guy as a sum. So that's good to go. But guess what? Do you familiar? Ooh, it says again. Let's do it in blue. Do you find anything familiar? Well, the top looked like sine. And but it looks like the signs are different. So believe it or not, f of x above was equal to negative sine x. So once again, could you have recognized that from the beginning? And what if you took the antiderivative of sine x? Well, the antiderivative of negative sine x is just cosine x, right? Plus c. But guess what? Boom, that's cosine x. So once again, knowing these popular dudes and how they're manipulated a little bit could really, really help yourself out. I don't know about you, but I think that's awfully cool how that works out. Here we go. Let's go to example 6. In 6, we're going to use those famous dudes even a little bit more to help make these things easier and easier, Japaneseer. Okay, so example 6, I think I got my pen back. Let's get through a problem. Come on, hook me up. All right, this says it's a Maclaurin series. Okay, for this, and it says find the first non-zero and the general. Well, since this is Maclaurin, shoot, I should use that dude I have memorized. Sine of 0 is 0, so that means I start at x. Okay, now I want to have this bad boy memorized because this is how okay it would be. All right, so is that 4 non-zero? That's 4 non-zero. Let's write the general term down here. Maybe that could be helpful. Remember, that would be a negative 1 to the n. It'd be an x to the 2n plus ichi all over 2n plus 1 factorial plus dot, dot, dot. All right, let's go. Now, we're just going to do now sine x squared. So guess what? All I got to do is wherever I see an x, substitute in an x squared. So it's going to be x squared to the third over 3 factorial. So if this was on my AP exam, this is all I would have to do. Or, believe it or not, you'd have to go through that crazy long process of finding all the derivatives, right, and writing it all out. But since it's Maclaurin, since it's one of these famous dudes that we use all the time in class, I can kind of cheat it. And believe it or not, you can even cheat it for the general term. You sure can. Well, how do I cheat it for the general term? Well, negative 1 to the n. I'm going to go ahead and substitute that x squared. I'm going to raise it to the 2n plus 1 power all over 2n plus 1 plus dot, dot, dot. And then you just, if it was a multiple choice, you make sure you simplify that, right? So if I just wanted to rewrite this simplified, it'd be negative 1 to the n. It'd be x to the 4n plus 2 all over 2n plus 1 factorial. And there you go. That's your bad boy right there. You're good to go, right? Okay, plug in a 0. Plug in a 0 there, we get x squared. We want x squared over the easy peasy, Japoneasy, right? Plug in a 1. You get x to the 6. Guess what? That's x to the 6 over 3 factorial. Kind of cool how that works out. Make sure you have those bad boys memorized. All right, and how about it? I got through a whole problem. So here we go. Example 7. Okay. Example 7. Oh, I know cosine x, right? And remember, it's always good to start with what you know and build upon that. Okay, it says find the first 4 non-zero and the general term. All right, so cosine x. Well, cosine x, cosine of 0 is ichi. So we start out with ichi, and then we're x squared over 2 factorial plus x to the 4th over 4 factorial. Minus x to the 6 over 6 factorial plus dot, dot, dot. Plus we have an alternator, right, class? We're skipping 2, so it'd be 2n all over 2n factorial plus dot, dot, dot. You know what? When I'm doing these, shame on me. Hit pause and see if you can write it out. All right, now what do we do if it's x times cosine x? Well, I'm just going to multiply everything by x, right, by x. You should have seen my feet. It was a dance move. All right, so if you multiply everything by x, we get x minus x cubed over 2 factorial plus x to the 5th over 4 factorial minus x to the 7th over 6 factorial plus dot, dot, dot. Plus, I got my alternator. That's good to go. The bottom stays consistent, right? What changes? You are going to multiply that by an x to the 1st. What do you do if it's the same base? You add the exponents. Boom. So it would be that, which makes sense, plus dot, 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 right? And you can check some terms, 0, 1, 2. But once again, even think about doing this the long way. right? If you didn't have cosine x memorized, you would have to do the derivatives. And when you do the derivatives, it's x times cosine x, which is a product rule. Whew! I dare you to try to do that bad boy by hand. Have fun with that. All right, here we go. Find a Maclaurin series for this guy. Whew! What's going on here? Well, shoot. It looks tough. If I did it the long way, have fun using up a whole page of paper. But hey, I know what e to the x is. E to the x is just 1 plus x squared over 2 factorial plus x to the third over 3 factorial plus plus. What would that be? That'd be x to the n over n factorial plus right? Oh, I know what e to the negative x is, right? That just means wherever I see a x, I'm going to plug in a negative. So that'd be minus x. That one would be a negative x squared, which would still be x squared over 2 factorial. My next negative, oh, that would turn it into a negative, right, class? Because you have negative x to the third power. Oh, so it's, okay. That alternates. That alternates. So I just need an alternator in that bad boy. How about that? That's all I would need. And that would be, shame on me. I should show this the right way. And I already wrote, and I can't erase. So, that, right, the way I really should have wrote it was negative x to the n over n factorial. And I can split that up, right? That is technically negative 1 times x to the n over n factorial, which is equal to negative 1 to the n times x to the n over n factorial, which, yes, is that. And you could have created that because you knew there was an alternator, right? Oh, snap. I'm not even done with the problem yet. Okay. Now let's actually do the problem. H of x. What the heck is h of x equal to? Well, it's e to the x. What's e to the x? So I am going to add these two guys together. So I end up with a 2. Oh, those guys, schling, go away. Oh, I got 2 of these next guys, which would be 2x squared over 2 factorial, right? Schling. I'm going to write out one more just so I'm okay. I'm going to have 2 of them, all right? I'm going to have 2 of the x to the 4th over 4 factorials, right? And then spling, right? Those will cancel. I'm going to do one more, 2x to the 6 over 6 factorial, right? Now, ooh, snap. And I have to divide all of that by neat. Oh, snap. Spling. Okay. And I need a plus ... But maybe I'll simplify that up there a little bit. Shoot, so I should use squigglies until I'm perfect because I'm just kind of, and I would end up with 1 because all those 2 cancels out, plus x squared over 2 factorial, right, class? Plus x to the 4th over 4 factorial, right? Plus x to the 6 over 6 factorial. And if you're on it, you're saying that looks awfully similar to cosine, and it does, but it does not have the alternator. So that's just x to the 2n over 2n factorial plus ... How about it? Not bad, right? Not bad at all. Did I get it right? I bet you I sure did. Spling. I got it right. Okay, now, now try to be honest. The challenge, there's your challenge problem. I mean, you've got, I'm gonna give you a hint. You've got to factor out an I. You got to factor out an I of the terms that have I's. And if you can get that on a piece of paper to me tomorrow, I got a surprise for you. Okay, I do. I know if I'm mistaken, I want to give you some homework problems, so hang tight. All right, so looking at our example 3 worksheet, before you walk in the door next class, you need to have donezo. Okay, you need to have done. You know what? Let's just have the first 2 pages done. So 1 through, I'll go 1 through 9. Okay, 1 through 9. Okay, I want those done. All right, because I don't think this video went too crazy. Aloha, see you in class 9-3 done. We got 2 to go, BC.